Hello, and welcome to the Science Hutch. Today's science is slope-intercept form, but I'm not Science Hutch, I'm Science Victor. Welcome back, my friends. Slope-intercept form is one of the many ways to represent an equation of a graph. It has many limitations, but it does serve a pivotal role, especially in physics. The actual formula for slope-intercept is y equals mx plus b. In this, y is the output of the formula when you input a given x value. M is the slope of the line, and b represents what the y value is when x is 0. I know that makes absolutely no sense, but it will shortly. The easiest way to think about the b term is what the initial value of the quantity being graphed is. Let's say that we're looking at a displacement versus time graph of a car driving down a street. At time is 0, this case meaning x is 0, the car still has some displacement, even if it is 0. The quantity is what you plug in for b. If there is no displacement, b equals 0. If the car is 5 meters in front of a starting line, then b is 5. 5 meters behind it, and it's negative 5. Pretty simple, right? The slope of the line is a measure of how quickly the graph rises or falls. The steeper the slope, the larger m becomes, until it becomes vertical. Of course, then the slope becomes undefined because you're dividing by 0, unless of course you do some weird calculus stuff and you start rearranging equations to be in terms of y instead of x, in which case you get a slope that equals 0, just in separate dimensions, and then you could turn it into a parametric representation in which you could take the second derivative and then integrate to get a proper slope, and you know what? None of that stuff made any sense, and you don't really need to know it anyway. Just know that if a line is vertical, it has an undefined slope. If the graph goes down as x increases, then the slope is negative. If it goes up, then the slope is positive. The way to calculate slope is pretty simple. It's as easy as rise over run. In order to calculate the rise, you must take 2 points on the graph, then subtract the y value from the point on the left from the y value on the point on the right. Next is the run. It comes from subtracting the x value from the leftmost point from that of the rightmost point. You can then divide the two quantities to get the slope of the line. You can do the same thing with data that you collect in the real world if you must create a graph by plugging data into this formula, which is exactly what we just did, but it looks a lot more nasty than the other stuff. Similarly, if I had to collect this data in the real world, you can follow the same process to get m, along with the b value you already determined, to create a graph so you can predict where the car will be at a given time. And that's really what the purpose of graphing anything in physics is, making predictions about the future based on what happened in the past. The equation y equals mx plus b can be applied to many circumstances, anything from springs to kinematics to forces to momentum to countless many other things, but you will learn a little bit more about those in our video on linearization, where you will get a little more practice with slope-intercept form as well as some other equations. Until next time.